Let's go through equal 2333 minimal sum of square difference. For this question, it gives us integer array nums1, integer array nums2, and k1, k2. We can manipulate nums1 k1 times, manipulate nums2 k2 times, and then we try to find the sum of square difference. We need to be the minimum. So square diff defines, for example, this num1, num2, the difference between 1 and 2, and 2 and 10, 3 and 20, 4 and 19, and sum them up. So, the current diff is that for every element we find the same index, the diff, and have a square and sum those up. Of course, you say that n and n1 both have the length n, and so we'll say, for example, number 1, that is 1, 2, 3, 4, and the number 2 is 2, 10, 20, 19, right? So what we think about is that for this each have diff 1, right? Because we will get a square, that is this 8, right? This is 17, this is 15, right? So we'll say this one can manipulate k1 times, this can manipulate k2 times. It is actually the same as we manipulate for this diff array k1 plus k2 times, right? So we want to subtract the difference from the biggest in order to get the summation of the square to be smallest, right? We should try to get the biggest one smaller first. And so the first step is that we change this one to 16, and we use 1 times, then 16 change to 15, right? Then use two twice, and then we have difference, which will be 15 when appear twice, right? Then we can change, for example, change this 15 to be 14, right? This also change to 14. Then this can minus 2 again, right? Until we use out of these counts, and for example, we left 1, 8, 10, 10, right? If for example, we have used if we have 12 times, right? K1 K plus K2 equals 12, then when we doing like this way, we left 1, 8, 10, 10, then we sum of those kind of square the difference up. So let's begin to write code for this. And we know these two areas have the same difference, so we have length equals nums1 per length. And we're going to have a diff array. Well, what does this one do is that we count actually, for example, this is 1, right? 1 will appear once, but we have a difference that is 3. Actually, this difference we use absolute value if it appears twice, right? And we have absolute value of 5. It appears 5 times, right? So for example, then we count the diff and their counts. So we know the range, the data range. You'll say number 1, number 2 is in this range, right? So the diff we can have new into this kind of range, right? Because the worst case is number in number 1, number 2 is 10 to the power 5, and another one value in the same index is 0, right? So we are going to have 4 if I put 0, right, smaller than and I plus plus, right? So we'll have in the current diff diff equals the next dot abstract value nums 1 I minus nums 2 I, right? Because we just need we want to calculate the square sum of square, so we just need a absolute value, but that should be fine, right? So we'll have diff current diff. We need to get its count, right? And we can also have the max diff here to when we iterate when we calculate from the largest one, right? Largest diff, for example, it is 1000, right? We don't need to iterate from 1000 to this number, the right end. So we can have another variable called max diff. So let's write max diff here. We call max equals to 0, okay? And max diff equals max dot max diff and current diff. And also there is another termination is that we have a total operations that is K1 and K2. We have in the count. Let's use long because K1 and K2 they may both to be 10 to the power 9, right? So let's have long count. That means that is total operations that we can use, that's K1 plus K2, right? So we can also have a long total diff equals 0, okay? So total diff we just add equal to current diff, okay? So we say if this total count greater equal to total diff, right? That means we have enough operations. All of the number in num2 and num1, they can we can use some kind of manipulations to keep them to have them the same. So we just return 0, okay? We can have convert this one to integer to a long, okay? When we add, let's do this. So what we are going to do is that we are going to iterate for if I equal to max diff I greater equal to 0. We'll say and count greater than 0, I minus minus. In this case, we can begin to use to subtract the counts. So by the slot, right? So for example, diff this is diff I, right? Diff I, it appears k times, right? So if we already calculate here, we have the count. If the count minus diff I, if a count minus diff I is greater than 0, then we get the diff I to be 0, right? And also diff I minus 1, right? Will have add k times, right? Add k times. Then count. This count will minus equal to k, right? So that means then we go to the next smallest bucket, right? And if we go to some kind of places, for example, diff I, the count is already smaller equal to d5. What we are going to do is that we just have the count equals to 0. And this d5 is minus equal to count, right? And in after doing this kind of operations for every diff, we have its counts, and we sum them up. So let's recall for this. We have two scenarios. That is the first one is if I greater or equal to count, right? That means those kind of calculations will end at this i's bucket. So I have if I minus 1 plus equal to count, and I have count equals 0, right? Because we have count equals to 0, we can terminate this for loop. And also we have d I minus equal to count, right? Else, that means for this slot, we need to use them out. So we'll have if I equals to 0, and we'll have count minus equal to d for I, and we'll have d for I minus 1 plus equal to d for I, right? So doing like these manipulations, what we are going to do is that in the end, we need to sum those kind of things up. We have long result equals to 0. And for I is the difference, right? For from of course we can start from 1, right? From 0 or 1 doesn't matter. I is smaller than max, right? Smaller equal to, right? Because it's possible that the max diff weight appears a lot of times, and we still didn't go to the next slot. I plus. So I have result add equal to. So the square is I multiplied by I, right? The square. And how many times it appears is if I, right? And let's convert this to long. In the end, we just return result. Current diff equals map nums, okay. And 32 diff. I'm trying to see some other results. So we'll see here that is OM operations to calculate those kind of diff array and some max total, right? And also we have this kind of space complexity, and we are going to do is that we just have the bucket, right? So the max diff theoretically, the worst case is this kind of length, right? So the space, this kind of complexity, the maximum is this one, right? Actually, it is just the max diff, right? So this time complexity. This will be the space complexity.